So the main reason why I'm doing this video is following some tests, some load testing tests that we've run last week. We've been asked for more load testing data, and we didn't have a lot of load testing data. We've done a lot of load testing for as long as we've been developing Ganister. The main issue is having a constant measurement point or measurement scenario, and we used to do different scenarios every time. So we knew if we were doing doing something wrong and the performances were getting bad, or if we were improving something and performances were getting better. But we couldn't tell a clear comparison for someone external. We couldn't say if it was getting better or anything like this. Mainly because we didn't have two things. So the measurement points, so a standard way of testing performances. Our values were changing all the time. And the second thing is data, real data. So internally, we have customer databases upon which we are testing performances, and that helps us a lot. But we can't use them for officially testing performances. So we need to build specific data for this, and building bit of materials is taking a lot of time, and we're not a big team. And we're mainly working on a product itself. We're not preparing a lot of demos, etc., or a lot of data sets. So I wanted to build something, a small utility. This is not Ganister. This is what we've called BOM generator. It's going to create bit of materials that we can then upload to Ganister, and that's what I want to demonstrate or present. And it's not a released product. It's going to be an internal product, and it's still in development, so there might be some issues. But so here, let's try a very small generation of bit of materials. So it's a small project. Just a few, little bit of code that we have in here to generate our bit of material. And this is configured as with these setups. So BOM depth, it's a min and a max value of how deep your bit of material will be. So let's say it's going to be from 3 to 4, just for a start, or 2 to 4. BOM count, how many bit of materials you want to create. So basically it says how many heads are you going to have in your bit of material. So let's say 3 to start with. How many parts you will have in your database total? So let's say 100. And the BOM width is how many, on each level, how many children do you have for a part? So there's a min and a max because we don't want everything to look the same. So we have some sort of randomness to have different structures. So we say between 2 and 5. From 2 to 5. Then we can run this. And so then we have a front end to look at our data. So depending on the scenario, sometimes all the bill of materials are the same. We still haven't try to make sure bit of material would be different because there's some randomness. So when bit of materials are picking their nodes, then maybe it could happen that these BOMs are the same. Here, we got lucky, they're not the same. So it creates all these parts and all these information here. So we can do more. So this is still a small data set, but it's just to make sure that it works. So if we go, let's say 8. So it doesn't mean that it will go down to 8 level. So 1, 2, 3, 4. Sometimes you see here 5. Maybe sometimes they're called, on the same level. So it might be up to 6 if you try again. Yeah, here it's getting a better depth. We don't generate a lot of properties, so to make it more realistic, we need to add more properties. We have a few properties. We have a name, description, and we have a quantity also on the relationship. But so then if you want to grow these numbers, the issue at some point is that because we're loading the whole data set on the client side to display this a bit of material, it's going to be quite slow. So then we will stop displaying this after a certain amount of nodes, and we just save these nodes in Excel files, which we then import in Ganister to do our test. So let's try a big one, or a much bigger one. So 50 bit of materials, 3,000 part count, BOM depth from 5 to 8, let's say. Part count 4, let's say 5 to 8, 10 parts per level. That's 8. 8 is fine. And so it's going to take much more time, mainly on the first, when they create the first bit of material, and then it reuses a lot of parts. So let's try this. All right. So we generated the data. We are building the Excel file. We'll kill this one. We don't want this one to be displaying the data. It's too much. So I emptied out this database. So we shouldn't have any part. Now we don't have any part. Let's try to let's try to see where the Excel file is. So in output, we have an Excel file here. So I'll open this Excel file. Okay, so this is a simple Excel file. As I mentioned, not a lot of properties. We have a part tab, which lists the 3,000 parts, and a bill of material tab with quantities. So you have source, target, ID of the relationship, and quantity. So how do I import this in Ganister? I kill the server, npm run data loader. Export templates. We just want parts and part BOMs. Parts, part BOM. Oops, part BOM. So this is how we import data from Excel files. If you have a lot more data, then we use ETL tools to generate CSV, and we use this tool again to import the data. So we have a part tab here. So let's transfer all these. We could, from our BOM generator, we could generate the output directly, but we don't, because this template here is based, this is not hard-coded, this is based on the data model that we create. So if we change this, then it wouldn't match anymore. So we have this, but you see we skipped some columns because for now this is the same column. So ref, name, description, here it is, and path BOM. You see in the template, orange means mandatory. Light blue is system. Dark blue is any other property. I guess, yeah, custom properties. Okay, in here, oops, I didn't take the first one. Let's get back to path BOM. And here, okay. So I'm just saving this back to my server, npm run data loader. Import data, yes, Excel. Hopefully it doesn't take too much time. Okay, so now we start the server. So you see there's been 3,000 paths imported, 3,728 path BOM links. There's a lot of reuse. Okay. So now if I go back here, let's take this. Okay. So now the path BOM headers. So the top part are, I think we created 50. So it's going from PRT 0 to PRT 49, I guess. So let's take PRT 0. There's no PRT 0. Let's find out. Oops. There should be a PRT 0. So let's see if there's a PRT1. Maybe there's been an issue in the import. I don't know. Let's try to expand up. So here we have a sample of data. I don't know why I couldn't find PRT 0. Potentially it should be linked to something at least. So if we, again, this is experimental. We seem to have it in the import here. Or maybe we didn't clean all the data and it was, no, it wasn't there. Or maybe there's an issue with the ID generation. But basically that's what, so let me check again, description for part 0. We didn't find anything, no. Part 10. 10, and if I go the other way around, yeah, it seems like it starts at 1,000, but no, if I say 900, oops, yeah, it seems like there's been a mix-up before, or maybe an ID that was copied, and if I just check, I'm just interested in knowing if, no, okay. But anyway, this is how we import our data, our bill of material. And if you download Ganister, the import is as simple as this. And so then we can test these. The most data we fetch is when we look at this multi-level BOM. So for now, we just have parts. But if we had documents, for example, we could have documents here. In order to change this, you would have to go in your data model. And in the part tab, you could change this. So here, this is a simple multi-level BOM where you define on which relationship type you want to fetch data. So if this is a recursive or a relationship to itself, then it's going to be recursive, like here, part BOM. If you want to add documents at every level, then you just add part document. And if we add a document, if we create a document, let's create a document here. So PRT 1928 PRT. So if you with large structure, what we have here is pretty good. Is the search. So 1928. So see now. And so if you select this, because you're lost, a little bit lost in the structure, you found the part you wanted, but you don't know where you are anymore. So if you just clean this, and now we have the document. There's no ref, so it doesn't show the reference here. But yeah, you have the document here. But so this is just a preview of how we build bill of materials for our testing. So in our process or officializing more our performances from one version to another, and I guess in the release note, we may try to display some of these numbers. We have to fix the types of the numbers that we're testing. So it means the script we're using. So we have this script when we use load testing, which means not just doing this, a refresh, but doing this with concurrency. So the scenario, the load that we're applying, and also the infrastructure that we're using. Is it a local instance? Is it an instance on the cloud, etc.? We want it to be as clear as possible, because in many situations, when you ask what is the infrastructure you should put, there's always been very broad description, because it usually depends on your type of usage. So if you have a better precision on what are the numbers that were used for a demonstration or for a benchmark, and what was the material used, what was the infrastructure used, then you can better decide what's appropriate for you. We've seen a lot of benchmark where company A says we can handle X number of nodes, but I mean, you don't know what's behind it. You don't know how the BOMs are made, if they're all the same, if there's reuse, if it's mixing different types of nodes, and what is the size of the infrastructure. You can always put more memory. At some point, the software could be the limitation, but still, if you need to put thousands and thousands of dollars every day for handling BOMs, that doesn't make sense. All right, so we'll do progress on this. We will progress on this and try to be as transparent as possible on the performances. I hope this was valuable for anyone who is a little bit technical on bill of materials and PLM. And if you're interested in the BOM generator, this is our internal product, but I'll be happy to share some of this code just to discuss it. And if anyone wants to get a demo, you just contact us. Have a great day.